6.5, the cosine law. So far the triangles that we have been dealing with have been right angle triangles. And we've been using right angled trig, SOHCAHTOA. That's one thing that I find that kids remember right through to the end of high school and even beyond. SOHCAHTOA, that's trigonometry. That is right angle trig because it requires a right angle triangle to do it. But the big question with the sine law and cosine law is, what if the triangle is not a right angle triangle? So what I want us to do is I want us to go through the proof of the cosine law today. But before we do that, there is a really important identity, it's called. So something that holds true for every angle that I want us to experiment with. So I'm going to go through the formal proof of the cosine law. I'm going to do a very informal proof of this identity, but I think it's worth it. So I want everybody to pick some kind of angle, some theta. I don't care what it is. I'm going to pick 65. And you guys should pick something other than 65 because that's what makes this identity amazing, that it works with any number. So what I'm going to do is I'm going to say the sine of 65 and I want to square it. Now the proper notation actually is the sine squared of 65. This is this right here is actually the spot, but this might be the way that you type it into your calculator. So when I bring up my calculator, this is what we're going to do. Oh, clear that. Clear. So the sine of 65 equals, I'm going to take that and square it. Equals. Good. Now here's the thing with sine and cosine law, it's going to be important that we don't round too early. So what I'm going to do is I'm going to hold that in my calculator. So I know what it is right there. So it's 0.82. I'm not going to write anything down. What I'm going to do now is I'm going to find cos squared of 65. I'm just going to bring up my calculator. So just pay attention here. It's 0.82. Yours will be different because you have a different angle. Okay, so 0.82. So I'm going to say the cos of 65 equals, and I want to square that. However you do that on your calculator. Interesting. 0.178. That's 0.118. What you notice about your sine squared of whatever angle you have and plus cos squared of whatever angle you have. My gut says that it's 1. But what I'm going to do is I'm going to prove that. Or I'm not going to prove it. I'm going to test out my hypothesis. So I'm going to say sine 65 to the power. No, that's the wrong place for the power. This is maybe what will be helpful. So open bracket sine of 65, close bracket, to the power of 2. I'm going to say plus, no, actually, I'm going to back it up a little bit. Because right now I'm going to try that again. See how difficult calculators can be? And sometimes it takes a while, actually, guys, to figure out your own calculator. 65, close bracket to the power of 2. Now I'm ensuring that it's the sine of 65 squared, not just the sine of 65 squared. And I'm going to add the same thing with the cos. Plus, I'm going to open the bracket here, cosine of 65, close bracket on the 65, then close bracket on the cos of 65 to the power of 2. Again, I can't reiterate enough that you guys are going to have to figure this out on your calculator. Let me know if you have any questions, though, because we can help. I can help you figure it out, and we can do it together. Look at that. When you take the sine of 65 and you square it, plus the cos of 65 and you square it, it equals 1. Guess what? If you find the sine of 52 squared plus the cosine of 52 squared, it equals what you think? 1. If you take the sine of cat and you square it, and you add the cosine of cat and you square it, it's going to be gross, but you're going to get 1. This is an identity that is going to hold true for any theta. So any angle that you can think of. Hopefully you found that with yours. If you didn't get it, my hunch is maybe you took the decimal and re-punched it in. I hope that you notice that I'm not rounding in any way. Okay, I'm trying to keep the whole entire decimal numbers, all the decimals, all together because otherwise we're not going to get a proper answer at the end. Rounding too soon, not good. So I think it's safe to say that if I say, identity, which is going to be important to this, this proof, I say sine squared theta plus cosine squared theta equals 1, always. All right, let's launch right into this proof, shall we? So, proof. Consider triangle ABC in quadrant 1 with AD perpendicular, that's just this notation for perpendicular, which is at a 90-degree angle, perpendicular to BC. So let's draw this thing. I'm going to draw it pretty big so that I can refer back to it. So I'm going to be jumping up and back and forth a little bit, but you guys just do that in your notes. So I'm creating this triangle here with AD perpendicular to BC. So this is a 90-degree angle, and also this on the other side is a 90-degree angle. So when we use our naming, what we're going to be using is the angle opposite to the side. Okay, so we're talking about this big triangle here, but we just have this perpendicular altitude here, it's called. So the big triangle, let's name the sides. So the angle, the length of the side that's opposite is going to be our little b. The length that's opposite to C is going to be little c. And the length that is, or the side that is opposite this A, this whole thing here is going to be little a. So now that we have all our sides and angles named, that's going to be helpful. So here's the thing. The coordinates of A we're always going to find it at C cosine of B, comma, C sine of B. Now we know this from our unit circle. This right here is the angle. Okay, so think of the A or AB as your terminal arm right here. If this were on the unit circle, we would say that this is cosine of theta, comma, sine of theta. But this is just taking into consideration the radius, because if you would continue on in a circle, this right here is really just our radius. Now it extends into a different shape, it creates a triangle instead. But if we were to consider C as our radius, now question, why in a unit circle is it just cos of theta and sine of theta? Well, because our radius is 1. We've created that. That's the thing that's most important. So this is just considering that the radius might not be 1. So that means that BD is C cos of B, and AD is C sine of B. So what I'm going to do is I'm just going to label that. So this I'm just going to highlight. It's all for you, Ken. this guy right here, BD, is going to be C cos B, and this guy right here, AD, is going to be C sine B, which makes sense with our unit circle, right? We're just taking the coordinates here. And also in triangle ADC, DC is just going to be A, so this whole length here, minus this bit here. A minus C cos B. So I'm just going to grab my green, and this piece right here is going to be A minus C, oh, don't forget that C, C cos of B. Okay, so what we're going to do is we're going to use Pythagorean theorem. To solve for B, little b, so this guy right here. So what we're going to do is we're going to say b squared, oh I shouldn't capitalize it because it's a little b squared equals, okay, if we're using Pythagorean theorem, we're going to say, little b is the same thing as AD squared plus DC squared, because this right here creates a right angle. So that is AD squared plus DC squared. But hold the phone a second. We said that AD and DC are equal to other things. We know that B squared equals, so we're going to substitute in here, we're going to say that AD is the same thing as C sine B squared plus DC squared. So A minus C cos B squared. This one right here looks like C cos BC squared, but remember this is just the point C. So now we're going to use our sweet algebra skills and just FOIL it out or distribute it out. So C sine B squared is just going to be C squared sine squared B plus, this one's the tricky one, right? Because we have a two-termed expression. So it's going to be A squared plus 2 times A times negative C times cos B plus C squared cosine of B, or cosine squared of B. So let's rework the ordering here. So I'm going to say B squared equals A squared plus C squared sine squared B plus, okay, so I'm just going to check mark these as I write them, just so I don't miss any, plus C squared cos squared B, which is here, minus, because when we simplify this, 2 times A times negative C, we're going to have a negative out in front, minus 2AC cos of B. All right, so we have B squared equals A squared, and what I notice about these next two is I can factor out a C squared from both, plus C squared times sine squared B plus cos squared B minus 2AC cos B. But wait a minute, sine squared B plus cos squared B. Let's go back up. Any angles that are the same, if you say sine squared of theta plus cosine squared of theta is 1. So this right here just simplifies out to 1. So b squared equals a squared plus c squared times 1, which is just itself, minus 2ac cos of b. Oh my goodness! And that's what we have. Now, we're finding the length, okay, this length of the side that is opposite of the angle. I can rework this this formula in any way. Say I'm looking for if I'm looking for length squared, I'm going to say that that's b squared plus c squared minus 2bc cos not b but a. Or I can find c squared. That's just a squared plus b squared minus 2ab cos c. So the letters are not necessarily so important here. You guys are going to have to be able to say, okay, I'm given a side that's like PQR and I need to find out the relationship. So remember, this b or this length here is going to be opposite the length of the angle, or opposite the angle that you have given.